Cool. So yeah, this is then the official start. Um, I'll share my screen some quickly just to present briefly what I had in mind for today. Of course, this is not gonna be like a thing where you expect me only me to speak. The idea is that we all engage and we go through the book and speak about it. And if someone has a question about it and someone has a nice answer, then this person gives the answer and so on. So this is the first session, so it might be a bit messy, but the idea is to, with each sessions collect like some data and fine tune it a bit further and make it better. So I'm gonna learn from this and as well as you. And the idea is to make great sessions. So first of all, I wanted to say thank you. Thank you for being here, for joining. This thing was crazy. Uh, I've never had that many notifications on my phone. Uh, it was a very hard day to focus and to do actual work actually. So yeah, this thing exploded. It was crazy. It was great. This thing that has a bit less likes was also quite crazy. The same author, Sebastian, uh, saying that uh, uh, he might join some of the sessions. Uh, is also quite incredible. So if we stick to the plan and talk talk to each other every week, we might see Sebastian over here someday. So that would be great. And some of the reasons of why I think we should do this session is to ask stupid questions because we are all here like learning the same from the same book. Some people might have more experience, other people might have experience in other areas. So I guess this messy combination can lead to some cool things. Um, then to discuss about what we read, so the chapters, so the concepts stick better. I guess like from reading the book, then maybe playing with the code examples, and maybe then taking notes from what you're learning, and then reading the people's notes, and then speaking about it is like too many points of interactions with the same concepts. So I guess it should make a difference when learning. And then the final reason why we should do this session is to learn from each other, basically. So what are we going to discuss today? The idea is to discuss about chapter one, which is a pretty easy read, I think, and quite fast. So that's why this week we'll have two chapters. So chapter one, which is understanding large language models, and then chapter two that has a little bit more meat that has already like code and some some examples uh, that are not trivial, like tokenization, by pairing coding. We also get some PyTorch stuff. So those are some ideas of what to discuss about. So yeah, that's what I was thinking. So feel free to open your mic to ask any questions. Of course, if somebody is asking a question, don't don't open your mic and go over that person. But yeah, just feel free to join the discussion. Uh, so I was thinking of, I have the book here online, and I also have it here, which is great because when you buy it from money, you get both versions. But it's quite useful uh, for for today's today's meeting because we can go over it and basically discuss. So first, does anybody has an interesting question or point of view from this chapter, something that you learned that didn't know?
Can Can you hear me?
Yes.
Yeah. So, I mean, for me, interesting part was that the large kind of language model split into two. So one is like unsupervised training and then the fine tuning. So I was expecting this to like actually work together. So, but it felt like the big chunk of compute is going into the getting like the weights together, and then they're putting the fine tuning.
Mhm.
Is this correct?
Yeah, that's correct. This is so yeah, basically we have these two stages of like pre-training where it's basically we just have the whole internet data and we train a machine to just predict the next word. And at the end, that's something that is not that usable because it just only knows how to predict next word. But it's quite crazy that after that, after you have that like foundation model, you can do lots of crazy stuff like classification, summarizations, translation, personal assistant, uh, text completion, and stuff like that just by fine-tuning it with the right data set. And this data set doesn't need to be as big as the whole internet. The other day I was reading a tweet, which was quite funny. I tried to find it today, but I didn't. Um, So the before the foundation model, it's you are pre-training, right, with lots of data. And after you have that pre-trained model, you fine-tune. So the tweet said like, when are we actually like training these things? Because we're always talk about pre-training and then fine-tuning and never about training. Uh, that was just an
But
interesting
but
thought.
yeah, the question is here, but is this the fine-tuning part where we have these like ChatGPT versions like 3.5, or is this is where they put the effort, or where does the kind of the incremental better state is coming in?
Hmm.
Why models get better?
I guess someone can correct me, but I guess let's say these new versions are because they are fine-tuned with more data, better data sets, better instruction data sets. Uh, that's my intuition about it. I don't know if someone.
Um,
Yeah,
Fine-tuning on a pre-trained model will cause the forgetting, no? They are probably creating the model again from scratch.
But you think even the pre-training, because the pre-training is quite expensive.
Uh,
the large labs are
yes,
definitely doing new pre-training, right? So when they're doing GPT-4 or they're doing new Gemini, they're definitely pre-training from. They might make a smaller model, distill it from a smarter model, right? They'll do that.
Mhm.
But I think you are pre-training from scratch, and I agree that data quality and data quantity is probably where the largest gains currently are happening. There are also architectural improvements, but I think data quality is probably the in recent
Yeah. So
times the largest gains.
there is also one thing that is not mentioned here because this is a simpler version, but this is like RLHF, that is reinforcement learning with human feedback. So that is a
Mhm.
very big difference,
Yeah,
from other, more traditional models. That is what sets, OpenAI things different.
and there's a there's a blog post this, and I think there's a diagram. I know. Well, this is the diagram from this Instruct GPT paper, which is a paper that but basically set the foundations of how ChatGPT is trained. So let me see if so basically what of course someone can add as well. So basically but this is yeah, wait, I just think I wanted to find here. So we have low quality data, which is like Wikipedia high quality, but the overall like data from the internet that OpenAI, for example, just uh, scrap. You build a large language model by pre-training it. Then you have demonstration data that is like this labeled data set that can do things like classification or whatever the task is. And then you do supervised fine-tuning, and then you end up with a supervised fine-tuned model. The diagram that we have here is just this part. This diagram is just this part until the fine-tuned model. But as Rito is your name, as Rito was saying,
Yeah.
OpenAI started playing with reinforcement learning from human feedback, and basically they built a comparison data set, which they built it by prompting the supervised fine tuning many times over the single prompt. They ask the same prompt multiple times, let's say 5 times, and then a human goes and rates those responses or even improve the responses. I don't know. And then build this relatively small data set, which is from 100K to 1 million comparisons, and then use that to do like another fine tune, but now with like reinforcement learning approach. Like you have a reward model, and I don't know, it's a bit more complicated, but then at the end, the idea is that you end up with a model that sounds a bit more human-like in the sense that
I thought that they're working on AGI, but now they have the human in the loop.
there's humans in the loop when training this.
I had a question, folks, and Santiago. This is Naveen from Bangalore, India. Yeah, I was wondering, how do we go about actually implementing the code, and how do we share it between ourselves? Any thoughts on it in terms of? I think there's a real meat or experience we can get from actually implementing some of the code. Any thoughts on it? Anything that would be good to share before we go deep into the weeds of the book? Yeah, thanks.
Yeah. Well, what I've been doing is just I think is replicating the examples. No, it is not this. Replicating the examples that are in the book on my own. So right now I only have chapter 2 because that's how far I am. But from sharing, yeah, I didn't think about that. Since this is basically the same that Sebastian has in his book, but I don't know if you meant anything else.
How different is this book examples compared to what Andrej Karpathy did on GPT, video explainer?
I think Karpathy approach is from even more scratch, because he builds the intuition.
ما ادري هذا نزل له.
Can you unmute yourself?
انا هاي فاتح الزوم وما قاعد احصل. شو هذا دخلت.
Mute him, like.
Yeah, I can, I think. Okay, I think I did. Okay, I think I did. So I feel that Karpathy starts from even more like deep, because he starts like building the intuition to get to this that's probably why the videos take like 2 hours, 3 hours long. But it's pretty cool because for example, I think I have some examples here.
And Andrej has a YouTube series on BPE as well. I found it really helpful when reading the chapter 2. It's about 2 hours long. It's really worth it.
Yeah. Yeah. And
Can
Andres
you share
videos
that link for that video?
yes, I'll
Sure.
share it in a second. Please, if you are not speaking, please mute. I just mute. Okay, cool. So yeah, and Andres, for example, this was from a video from Andres that he's building something that's called microgrid. It's basically gradient descent, but from scratch, his own approach. And he starts like the first thing he starts doing is just trying to like with from a simple uh, equation, not equation, but from single function. We try to like model it ourselves. We try to tune it by hand, and then you start like from there start implementing each of the stuff that are in gradient descent and trying to replicate this, like how the gradient descent in PyTorch is implemented, but like from single version, and then how you do back propagation and how to visualize it and all of that. So it's very like stuff that wouldn't be inside a book because otherwise it will be like lots like this size and lots of code, but in video format it works great, and he explained it in a very nice way. So that's why I said that this Andrew series is a great complement to the book, because maybe the book is more, it's from scratch still, but a little bit more fast, and maybe you end up with some knowledge gaps in between. That if you look at the series from Andrew, it all starts to make more sense. I click you.
Yeah, I agree. Like I have done the video of Kapati, and like the benefit is that it helps you understand the math and it makes it more approachable. And that's something that like I didn't think it was gonna be that easy. So if you want to like complement the math side, you should definitely go and watch the series. And it's not that bad. It's actually quite
Actually,
fun.
there is a very nice series on YouTube about, I don't know if you guys know this channel. It's called Three Blue, One Brown. They started creating a series of videos on how LLM works from the mathematical perspective, and really recommend them.
Yeah.
Actually, all of these self-attention mechanisms is very nicely explained. And I've seen lots in the comments that people ask about these parameters that we try to to get during the pre-training, and it's precisely these kind of are the weights on the neural networks that we're trying to optimize. In fact, I think like in chapter 2, when we talk about embeddings, there is like a reference about that. So like between the vocabulary and the embedding size, which is like 12K sort of digits that you try to get. So like this multiplication gives you the initial parameter size that we need to optimize. I mean, at least for ChatGPT 3.
Whatever that meant.
Yeah, I think it's like I think in chapter two it was like their vocabulary for the pre-training for for GPT-3 model was 50,257 words, and their embedding size is 12,288 dimensions. So when you multiply these two numbers, it gives you the initial numbers of parameters that you need to optimize for the neural networks.
Yeah, on that talk, well, we can discuss this further when we reach chapter 2, but as someone was saying in the comments, Sebastian also has like the GitHub repository for the book, and it has like bonus content, which I was looking at it and it's quite fun as well. Like he has a bonus section on bytebird encoding where he does some benchmarks between different implementations. In the book, we use what was it called? The library?
The tick
TikToken.
tokenizer.
The TikTokenizer, yeah. We use TikToken, but in this notebook, he also compares it with the version from Hugging Face, for example, and others. So we might take a look at that. But before moving on to chapter 2, let me just mute someone. Mute. Okay.
I have a question from chapter 1, if it's possible.
Yes. Let's go to chapter.
Which might be the practical difference between these two transformer architectures, like decoder only and encoder and decoder? Which are the practical applications for these two architectures? Did you have an idea?
If I may answer. Hello?
Yeah, go ahead.
Yeah. So before 2019, BERT, if you have heard of BERT, BERT and its variants are examples of encoder-only models. Those are not used anymore. Now, the majority of the models that we use nowadays are decoder-only, both in the LLM field and in ASR also. And there are some encoder-decoder models, far and few between. I think if I remember correctly, GPT-2, T5, these are encoder-decoder models. So in all practicality, I think currently decoder-only models are the best.
So can I add to that?
Yeah,
So
go ahead.
basically, with encoder only and decoder only approaches, you cannot get multimodality, right? So if you want to go multimodal, so like basically video to text or text to video or image to captioning or caption to image generation, those have to be like, if you are going transformer only, those have to be contain both encoder and decoder.
But the critical difference is the encoder is not part of the architecture. It's just like, for example, if you take Uni model, one of the early papers on multimodal LLMs, it uses a visual encoder separately. That's not part of the architecture itself to convert.
Yeah, that's why I added it. If it's transformer only, then you have to add that.
So the main difference I see is that it's on the training scheme. Like chapter 1 mentions, BERT-like model, which are encoder-based, learn from masked language modeling, while GPT-like models learn from next word prediction. They are for two different tasks. So in case where you want representation for the entire sentence at one shot, you go for BERT, because there is, I think when we go more deeper into this book also, we will see there are like special dedicated tokens called class tokens in BERT, which gives the entire representation of the sentence. So sentence transformers and most of those are based on encoder-based models, while GPT is more for like generative tasks. So that's the difference I see.
Yeah, I also share that vision. I wouldn't say decoder models are better than encoder models because it just depends on the task. For example, encoder models like BERT are usually cheaper to run. They tend to be smaller and they are very good at classification tasks. So doing sentiment analysis, document categorization as mentioned here. If that's the task you need to do, then go with a BERT model, let's say, and it will be cheaper to run. Uh, it will be yeah, basically cheaper and probably better than just calling the OpenAI API, for example.
And I was gonna add like the reason why we shouldn't like overlook the BERT models is that they're really good because they have this thing called bidirectionality, which basically like understands the word, not only like the next word, but also the previous word, which is why it's really good at understanding the context and ambiguous meaning. So, as you said, if you need to like do something with text classification, sentiment analysis, BERT models are still relevant. So BERT or Roberta models. So I think that we should obviously like try to like look into those first before just like making an API call.
Indeed. Yeah. Because of its bi-directional approach, you can have like the full context of the sentence as you said.
I
Great
have
question.
another question to ask, which is why is it that the decoder only models are always unidirectional when the bidirectionality could help in predicting the next token? I haven't been able to find a convincing answer, so just curious.
I think I have the answer. I mean, I think that I can answer that, and maybe someone can correct me if I'm wrong. So it's using something called causal language masking. So basically, for the next word token prediction, you don't want to give out what the next word is, right? So basically, for the generated task, it has to auto-regressively predict the next token given the previous information only. So if you give bidirectionality, that means it gets to see the future as well, which you do not want in a generative model. For BERT, the bidirectionality is important because it needs to get the context of the entire sentence to give one representation. So when we go into the deeper chapters, we will do causal masking. That means there is a causality. That means there is a direction. There is one direction. I hope.
Yeah, I think okay. I think that's a good reason. Okay. But once we've generated a few tokens, then for the okay, for example, let's say we have generated this is an example of how Kant says I can, and then we're generating the next set of tokens, right? The embedding built for the word example still was done in a unidirectional way, right? Wouldn't it help that once we've generated a set of tokens, the others could flow bidirectionally, if that makes any sense?
Like you can't see into the future, right? Like, I mean, at least in this case. So it works on a conditional probability that given this is an example, what could be the best next token could be. So that's the objective it's trying to maximize the probability of the next token. So like, I mean, it's really difficult to tell, I mean, to ask it to look at the future, right? If I make any sense, maybe someone should take a swing at this.
Okay. I do understand this is the case. Okay, thanks.
Yeah, I really like that answer that
I
you
think also
gave.
the tricky part here, Rena, is like even when you look at
Basically,
chat.
these are just human decisions. People played with a ton of stuff and then they just went with what worked best. Anything else is just speculation, like theorizing about it.
Yeah, I agree. Thanks.
Go ahead, the
Yeah, but
person that was.
it is also a good idea to know if something works, to know why.
Yeah, indeed. I think someone was giving a thought, an answer also.
Yeah, I was
Go
saying
ahead.
that I mean, if you guys look at GPT models, I mean, even ChatGPT, if you ask a sort of like a task that, easily will be performed by BERT type of model, still is able to do this thing as well. Like I'm just gonna paste that in the chat. So if you ask GPT, ChatGPT to fill in a missing word in a sentence, it will do this, as a BERT model would usually do as well. It's like, so maybe like, I mean, makes me think right now whether in production these type of models are optimized for general purposes, or just like depending on the use cases they just code and behave differently. I mean, it's kind of a bit tricky. I mean, at least I would like to understand.
Mhm. On the thought of uh, and between this and this, I also like to think about, for example, uh, time series problems where you want to predict, for example, we are learning about, I don't know, the sales of a company, and we want to predict the sales that are coming in next week. If we train a time series model by being able to look also at the future, that will probably give us like a very good model performance during training. But that's not how the real world works, right? You don't have access to, like, let's say I want to predict sales for next week, but I also have access for sales for in the next 2 coming weeks. So it wouldn't make sense to have a view from the future, because it is kind of a generative task where I want to generate next sales. So in that case, it doesn't make sense to have something like BERT, which trains in a non-time series fashion. I don't know if that make any sense, the analogy between this and time series, but I find it.
I've got a question.
Yeah,
Kind
go
of
ahead.
might be a stupid question. So, like, the book explained how Bert was very good at emotion recognition and like categorical tasks, and a GPT model, the decoder, was good at generating. Like, wouldn't it make more sense to stack an encoder and analyze what the text is about and get some insights, and then use the decoder uh, along with the encoder's output as an input to generate a better answer or something? Do you get my question?
I personally didn't follow the exact question because I was distracted by the background noise. So I don't know if someone else could follow.
Yeah, so I think what he asked was, isn't it better to stack a encoder like BERT on top of or in front of GPT to get the context or representation and then make GPT generate? Am I correct?
Yeah, exactly.
Yeah, so the T5 model and the T5 family does that. So T5 was was introduced by Google, which also had the one of the early cases of prompting. So you have to say translate this to German, and it does that, and then you have to say summarize this for me, and then it summarizes. So T5 did kind of language modeling where you have an encoder and a decoder doing this task. But I think down the line, they have felt that going for a decoder only model seems to be better. But I also have to read on why exactly they have abandoned the encoder part.
So I think it has to do with costs. Basically, you can make a model bigger and bigger, and it will give you better and better performance. But uh, you also have to think about training and inference costs as well, right? So basically, we prune models. We let go of some parts because they are cheaper to train and cheaper to infer on. So it's definitely better if you keep adding things, and that is one thing. And second thing is basically this is machine learning, and there is like many attention heads and many QKP pairs. So basically, those questions are getting asked somewhere in the embedding space. So that's why it's machine learning, many parameters and so on.
Nice. Any other questions from chapter 5? 1.
I would like to make a question, which is if any of you have any recommendation for trying to see the internals of mechanisms like these ones, like the encoder and decoder that we were taking a look at. Like, because to me, the experiences that I have had with the LLMs are when I try to monitor something of them are always things like Comet, OPIC from Comet or things like that, which is from the outside, what it inputs so as a black box. But if you have any recommendation for trying to debug cases like this one, like tools, I don't know, maybe just callbacks in PyTorch or something like that, or maybe using very tiny reduced versions of GPT-2 or something like that.
So you mean like resources to learn the internals of these two boxes, encoder and decoder, right?
Yeah, basically, yeah.
Yeah. So I would say my first suggestion, I think it's gonna be these two next chapters. I don't know, chapter 3 and chapter 4 are basically that. Because we will learn in chapter 3 about attention mechanisms, which is generally about the transformer architecture, that is this couple of things. And then the implementing GPT from scratch to generate tests is basically implementing this decoder part and all the layers that are in there. So I would start by doing that, and then we can see. As always, I always suggest Andrew videos. So I think that should be more than
So
enough
Carlos,
for an intro.
Carlos, if you want to really learn like what's really going on under the hood from a mathematical perspective, again, I would still recommend these videos from Three Blue, One Brown. I would just maybe put the link or send it to you on the chat. Because I mean it's very intuitive and it allows you to understand like what's really going on under the hood. But most of these things right now are, we got all already the models, and then when we import a foundational model, we just like importing the weight precisely because it's been trained already. So I mean, if we want to do this for educational purposes, I think we're gonna do this in chapter 3. But I mean, if you're still interested to go ahead, yeah, there are like loads of really nice materials on internet.
But I think the question was related, what Carlos asked was related about monitoring, right?
Yeah, I was asking in particular because when I have done, I have followed some of the videos that have been mentioned already, but the thing is that when I try to follow these things, it seems like it's just either a function, a very isolated part. So sometimes I want to get my hands on a working LLM, even if it's a tiny one, so that I can see what's happening inside. But yeah, that was basically the question.
Well, I really don't know if you can see that like in production, probably only for like learning purposes, like the website that we're seeing right now. Because I mean that would be really cool if there's a tool that does whatever you want it to do. It would be amazing. And if anyone knows, I would also like to know.
I am sharing a small link for transformer interpretability. So I think what Carlos is asking falls under the domain of transformer probing as well. I do not have much resources, but I do have one Streamlit, I think like a tutorial, so I'm going to put it in the Zoom link.
Someone shared, Nate the Great shared this link. The first time for me looking at it, it looks quite nice. So let's see, let me start there again. So it looks like we're looking at the whole LLM architecture here, right? We have inputs, So yeah, we have these inputs, and then apparently we tokenize them, right? And then what is happening? We're building the embedding. So yeah, this is chapter 2, if you can recognize it. We have the token embeddings. So the exact embeddings from these tokens here. We have the position embeddings. And if we remember correctly from chapter 2, these input embeddings are basically the sum. This is quite nice. The sum from token embeddings plus position embedding, right? So it looks.
It's very nice. A linear algebra is pretty much everywhere here.
Yeah.
Like everything is just about matrix multiplications.
Indeed.
Something, Nate. So this is a link that I found from X post. I can't remember which one, but I do have some questions relating to this, embedding part, from the book. I'm pretty new to this, right? So why do we go from? I understand we have some kind of sentence, right? Like it provided some sentence, and then we were trying to predict the next word. My guess is if you have some sentence, you have to encode it into some way where the LLM system understands it. Meaning embedding is just converting the words into vectorized space. So, and then I just don't understand, once we convert it to some vector, we add position to it, and then it becomes a position embedding. So what is the position here that we're talking about here?
I understand this as the position of that specific word in the sentence. So since we need to add some sense of position into the transformer architecture, since attention also don't have a position, an intrinsic position, the position embedding allow us to tell, okay, the word hello usually appears at the beginning of text instead of in the middle. That's the kind of intuition I built about why we need it, but I don't know if someone else has a better, deeper answer.
No, I also agree with you. It's just it's a sequential problem. A sentence is a sequence, and we need to know where exactly each word or token exists relative to each other. Otherwise, if you don't add a positional embedding, it's gonna be like bag of words. That means the order of the tokens gets mixed up. So this is their attempt of trying to give some kind of a order to the sentence when the transformer interprets it.
Yeah, basically think of a sentence like I am hungry, not sleepy. So basically, the position of the word not actually matters a lot because the speaker is not hungry, he's sleepy. So kind of like that.
And to me, I would like to say something just to be corrected because I am very new at this. But one of the things that surprised me was the two functions that we are normally using from the attention is all you need paper, which is we are using some particular case of position embedding, which can be, it does not have to be that one. But in that case, we are using this sinus for the pair positions and cosinus for the other ones, which is basically a solution for the problem that we cannot use integer numbers because they would become, if the text is big, they would become very, very big, and we need numbers that are, if possible, between, let's say, 0 and 1 or 0 and something that is in a tiny range. And that I think that helped me understanding that this was like a choice. We need to encode in the same way that we tokenize. We need a function that gives us numbers that encode the position so that we can then decode it. But it's not necessarily, it's not as easy to understand as if we were just adding a number from 1 to n.
Mhm.
But at the end, is that what we are trying to encode?
Indeed. Any other comments?
I think there is a question here in the chat about the ratio between the number of parameters and the size of the data set. And I read some papers on or some articles on Medium, and it seems that there are some scalability best practices. Like I'll share the link in a second. Like 20 tokens per parameter. Because in order to make a fine tuning, which we discussed, we need a data set, and the question is we cannot talk about the internet. We need to have a clear application in mind when we want to make the fine tune or the pre-training. So the question is how big the data set should be if we want to solve a certain problem. Like in this question, which Alexander Barbu asked, is if we want to make a kind of a C programmer expert. And how many tokens do we need in order to, or how big the data set should be, or what should be the relationship between the data set size and the number of parameters. And I will share right now the link which I found on Medium. If you can share it, Santiago. I think it's a scaling law. It's a scaling law.
I was not familiar with this law. How much did you say? Like 20
tokens per
parameter.
Yeah, I mean the question would be like, let's say you want to have something for one vertical only, and I said, okay, C programming, right? And you're looking to say, okay, I want to be able to use this on a mobile phone, or I want to make sure that I use the smallest amount of resources. So pretty much kind of have to be able to speak to the LLM, right? So probably you're going to be taking the weights from an existing one, which does the trick. Say we go with Llama, for the sake of the example. And then you want to see, okay, I'm taking those weights, and you have to kind of match the weights with the number of parameters. So that's a given, right? But I mean, like, if you only want to teach it something, you probably need, I don't know, like 20, 30, 50, 70 books, right? So how do you go about identifying the smallest number of parameters, thus number of resources, so that model is proficient and is able to help you, but within one thing only. So, instead of having one that does, I don't know, 100 things or 1,000 things, right, which is going to take a lot of resources at one time, it's expensive. You can have like 1,000 models, which are very small, and you can use it one at a time. So I think the trick is, I mean, everybody knows that if you're throwing more power and more parameters and more of everything, eventually you're going to hit the spot, right? But I think that if you look the other way and see, okay, what is the smallest amount of, let's say, resources that we can throw at this so we can get something that's proficient?
It's a tough question. It's only trial and error approach can answer such a question. I mean, there are multiple questions within your comment. And basically what you ask, if I understood you correctly, is what should be the size of the large language model. Then based on the size, which should be the size of the data set we should use for pre-training in order to optimize the cost. So based on my limited experience with fine-tuning, so only fine-tuning, I can say that it's a matter of, it's a trial and error approach for a particular application you have in mind, like having a C programmer expert.
Yeah, but when you think about it, and I don't want to digress and I don't want to hijack the meeting, I mean, it's rather hard. I mean, like, look at Qwen, and it does a lot of stuff. It's like 70 billion parameters or something like that. I don't know exactly right. And it covers a lot of programming languages, right? It covers a lot of languages like English, Chinese, and so on and so forth. So the idea would be, in my opinion, if you're able to say, okay, I wanted to do only English, and then I wanted to do maybe C programming or Python or whatever. Python, I mean, everybody can use something that's available for free. And I think that, okay, you definitely have to be able to speak with it. So you have to base it on something that's already built, because otherwise the cost will go through the roof. So probably you're going to be taking weights from another model in order to use those weights, because I spoke quote unquote with ChatGPT. Pretty much you have to match the parameter model numbers. So you cannot use the weights for Llama 400 billion with a parameter that is only 70 billion parameters. It won't match. So pretty much you're going to get from Meta the weights from the 70 billion parameter, and you can use that on your 70 billion parameter model, and you can play with the architecture. But pretty much you understand that the knowledge is within the weights, and pretty much you can fine tune exactly as you're saying up to a certain extent. But the fact is, if you can go much lower, because in theory, even Llama 3 170 billion, right, is really good, especially for everyday thing. More people are able to run it. But if you look at cost, you probably need, I'm actually running it. I have two RTX 3090s and I'm running Olama. So that's how I do it. So it wasn't, let's say, that expensive to get them second hand, build a rig, and I'm able to run it, right? But if you get a regular RTX card with, say, 16 gigs of RAM, you probably have to go much lower, up to some 7 billion parameters. And that's the thought process, and that's why I'm thinking about it, because, everybody's going to be able to run something close to expert level within their own PC. They just have to switch between models when they want to go from, I don't know, like engineering to chemistry, from then to programming, then to network engineering, architecture, and so on and so forth. So this is why I feel like, I mean, this is what I'm looking for, and I'm totally, I don't even know how to approach it properly. How do I go about making something as small as possible that will give more than average or very good results on on a single vertical only? So say
Yeah, but
whatever.
I guess that's like a whole research problem and question. Like, how do you still get good results with small models? Uh, I think there's a lot of
I think I
people
want
working on
to
that.
pitch in on this idea of getting good results from a single model. I think the mixture of experts, I think that's the underlying intuition behind it. If I'm not wrong, please correct me if I'm wrong. Uh, it's basically where you have a single model like the Mistral model, and uh, you have multiple experts that are trained to be good at different things. So I think the first model to truly put this into popularity was the Mixtral model, which was 8x7b, which is 7 billion models, which are uh, each a different expert. So for a given question, you will route, or a given input, you will route it to the respective models to answer it. The benefit being that at any given point in time, you don't have, okay. So if you had to load the full model, it would be like what is 8x7? It's 8 7 is a 56 billion parameter model. But then by using routers and mixture of experts, you only have a like either one or two experts at a time. So the max would be like loading a 14 billion parameter model. So that's how we get the benefit of using a small model, but a lot of performance.
Yeah,
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 this is it,
yeah.
yeah.
Go ahead.
Oh, that's great. So I wasn't aware of it. I mean, I had heard of it,
Mhm.
but I didn't know that actually you had like a front end identifying what you're looking for and then routing it to the correct model who can answer the question. But pretty much based on the input that he provided, it looks like 7 billion. So if you look at the 7 billion parameter model, it should be able to cover up to close to, or let's say mid-level to expert level on a certain vertical. So probably what I'm looking for is roughly a 7 billion parameter model. Should be able to handle something. I mean, let's say programming or part of the programming.
All right. So we're getting very close to an hour of the call, and I think we haven't spoken a lot about chapter 2. For me, it's all fine. We uh, continue discussing, but maybe somebody has to go and has some questions about second chapter. I don't know if what would you like to discuss about this one?
Can I make a suggestion?
Yes.
I did one of the more effective courses I've done. This part of this group called This Week in Machine Learning, This Week in ML, TWIML, and you can look up their blogs, their podcasts, and everything. But years ago, yeah, exactly. Years ago, and it's run by Sam Charrington. So they have these little courses under community. And so what we did was we did the book by, I am sorry, I'm blanking out. The book's right. I've got multiple copies of this book. The Aurélien Geron's machine learning book.
Practical deep learning.
Yeah, hands-on machine learning.
Exactly. So we did that chapter by chapter every week. And so we would have one person who would step up and take the responsibility to say, we're going to go over the entire chapter quickly during this period of time. By the way, these sessions were about 2 hours or so. When we start the Zoom, we would all go on a timer and do silent reading for about 45 minutes to an hour to go through the chapter ourselves. And then in the following hour, we would do it. So it's like you're carving 2 hours of your time, with the first hour being silent reading. You do your homework during that first hour together quietly. And then in the second hour, the person who's responsible for going over it, they would basically lead the study session to say, let's go through the chapter. And this is the most effective way to learn through it and go through the chapter quickly using both usually would like, for instance, when I did the sessions, I'd split screen. One side would be the book and the other side would be my notebook. And we would go through it very, very quickly. But in that process, we would all be asking questions. Naturally, you wouldn't be able to organically go through it because everyone's on the same page because we've all gone through the study session. We've all done silent reading. And then the questions would be just much more rich. Going through it, that book is a very thick book. So it took us, I'd say maybe, I don't know, anywhere between correctly 8 to 10 months. But it worked. It was, and Aurélien, just like Sebastian, would send like tips, like focus on this, do this, and so on. By the time we got the second half of the book, which was all deep learning, it was amazing. And even the machine learning part, even as an experienced data scientist, is all very, very valuable. And I was hoping, this course would be something similar to that. The book is 7 chapters. We could, in theory, complete this before the end of this calendar year if we approach it. So next week, if someone wanted to say, I'll step up and I'll take the lead for teaching chapter 2. But Santiago, you would be the coordinator, the project manager. You're making sure who's online, who's going to sign up to do it. And, if nobody signs up, shame on us as a community. If nobody signs up for the chapter, Santiago, you're going to be on the hook to have to make sure you do it. But some of us, I think, are very eager for our own learning, and everybody else that Santiago, you won't be doing this alone. We'll join you and make sure this is successful. I'll be quiet. I'll let you all react.
I think it's a great idea, Mesh. I had actually high quality experiences in the past on other study groups, and which follow exactly your approach. Yeah, we went through together through the text for, I don't know, 30, 40 minutes, and everybody has a minimum common understanding of what is going to be discussed, and then the leader or the volunteer for that particular session went into, let's say, went into a learning mode or something, or presentation mode, yeah, and then everybody asked questions. So I think this approach, it's by far the best what we have so far.
Yeah, exactly. But this was a really good session. I really learned a lot and loved the links, and this was really, really good already. But yes, I think if we make it more targeted and focused towards structured for a group learning, like a classroom with some accountability from all of us to make sure we understand the material, have our own questions, and we support and learn from one another based on our answers.
There is one idea that is, only slightly different. That is, instead of like 1 hour full silent reading, basically a chapter is broken into subsections. So basically, we'll do 1.1 and 1.2 for this 15-20 minutes. Then there is a session for like 3-4 minutes for asking questions and adding comments and explaining further and stuff like that.
And there was one other thing that was also valuable. Later in the day or the next day, somebody else also took the lead on the homework assignments. The homework assignments. Always.
Nice. Yeah, I really like that approach, and I didn't know about that. That was also one of my talking points for today's talk, like how can we make the most out of these calls? Because I knew first call was gonna be somewhat unorganized because it was only me, and I expected the chat to be also very, very busy, and it was. So I was only able to see as much as I could. But yeah, I really like the idea. I just have one question. This also assumes that the reader read the chapter before the call. So these 40 minutes, 1 hour, or section by section time is just like a rereading, right?
Correct.
So there are like 2 approaches. One is like you can do it live on video. That also, makes you, it takes you to the spot, and makes you totally, you can't slack off on it. So basically, you are forced to read it. So that is one approach, and another is you read it beforehand, and that is how it is done in Cohere communities, study groups. This is what was done there, and in Fast.ai study group, the other approach like live reading.
Yeah.
And I also suggest making a wiki instead of like a Discord random link sharing. Basically, making a wiki or a markdown wiki on GitHub. So basically, just create a repo that says this study group, and then under that study group, in markdown format, there should be all the shared links, all the notes, and all the blog posts that people would like to add.
Well, we still do that on the GitHub's announcements page, right? Or the general information if something is pinned. It still is. But yeah, whichever. Sorry.
Yeah, I like the idea. We can, or someone can just create a repo. We all add stuff in that repo and with all the links, and we pin that in the announcements so everybody has access to it.
For chapter 2, if there's nobody willing to take on, I can volunteer myself.
Yeah,
I think
that was also my next question.
Naveen
So,
wanted to volunteer me, but yes, thank you
Yeah,
so much.
okay, it's fine. So I
No,
can
no,
go
no,
with
no,
I can
no.
take the chapter 3, no problem. So it doesn't
Uh,
matter.
no, you can take chapter
No,
2.
please take it, Mash. It was your idea.
Yeah,
Actually, it was
Nash,
your
I
idea,
think
and
it'll help us
you
if
can
you
take
All right.
chapter 2.
set up the
I'll take the
template
next
for
one.
us.
All
Okay.
right.
Yeah.
I'll take
Nash,
chapter.
you can set the template for us. That will help.
Okay.
Yeah.
I'll hold myself accountable first.
Yes.
so,
Thanks for the idea.
Manj, just to also understand it correctly. So, just to agree on the roles, please explain me again the role. So, in let's say next session, we start the call. Each of us review the chapter silently, let's say 40 minutes, 1 hour. And then it starts like someone else, like giving like a lecture on the chapter, right?
Mhm. Let me propose this slight a change to what you just said, Santiago.
Okay.
I think coming into today's meeting, everybody was supposed to have prepared for chapter 2.
Yes.
So next Sunday, I'll come in and right away start to prepare. I'll start to present chapter 2. I'm going to have the code. I'll have the book, and we'll just go through it. Essentially, like any instructor, I'll be like any teacher instructor. Go through chapter 2. My goal is go through the teach chapter 2 in as effective manner as I can. Leaving it open where people can just raise their hands and ask questions, do the same thing we did today, keep that same rhythm and style going. But we won't do the silent reading for next week just because we should already have completed it. So let's just get right into the actual session of learning, running the code, trying things out. At any point, once I'm done, hopefully I'll be done soon, somebody else can take over to say, all right, I've actually extended chapter 2 and here's what I've built and let me show you this or so on. Let's dig deeper into the material for chapter 2, focusing really on just chapter 2.
Yeah.
All the way up through encodings, positions. There were some questions around why are positional encodings important? That was something I want to try to be able to explain very, very simply. Those sorts of things, let's cover that. So by the end of the 1 hour next week, hopefully we'll all feel like we intuitively get it and we've done the problem sets and so on.
Sounds good. Sounds good. I really like the idea. We can also go through maybe some of the bonus materials, but I think it adds a lot of understanding from how the things works.
Right. And I'll keep an eye on Discord if you all, as you prepare for chapter 2 yourselves, if you have ideas like, you know what, let's go on the bonus materials first or later or embed it this way. I'm open to any suggestion. Again, this is a group effort, not just my point of view. But my job will be helping to ensure that everybody understands chapter 2 very well.
And I think we could create also a pool on Discord to see who wants to take the lead for every chapter. And I think that the fact that you start the first one doing it, Mash, since you seems to have experience, that will give us a clear, or let's say a better understanding of how it should looks like for the other chapters afterwards.
Yes, please.
So I think that's a tremendous idea.
Excellent, Felipe. Yes.
And one final recommendation, if you don't mind, is I have had sort of the same structure in Santiago Valderrama's machine learning school. I don't know if you are aware of it, where we had courses also in Zoom and a Discord for the chats. And I always felt like we were losing all of the beautiful links and things that are submitted during the Zoom calls. So I would suggest that during the calls we use Discord so that we still, after the call, we still have all of the links and all of the things. I don't know if people.
Yes, please. And Santiago already separated all the chapter sections on Discord. So that, Carlos, that would be fantastic.
But isn't it a limitation for attendees on a Discord call? or is it very much unlimited for everyone?
No, but I think the call would still be here, right? So it's just the chat that we would move to.
Oh, okay, right.
Yeah,
Thanks for clarifying that.
Do not use Zoom chat, as Carlos said. Use the Discord chat for the chapter. So we all have the links. And Zoom is just for video screen sharing.
Right. Okay. Sounds good.
And it'll be recorded. And as Santiago said, he'll post and share the recordings as a private link on YouTube, and that's fine.
So, Mesh, if I understood correctly, then for next week, we're not going to do this silent reading. We should have already prepared the chapter, and then we're just gonna go through this.
Yes.
Hand by hand, right? Okay.
Yes. And you guys are all stuck with me, I guess, for chapter 2. 100%. And I'm gonna bungle my way through it.
Nice.
Everyone here is way, way smarter than me, but we are collectively, the idea is nobody is smarter than all of us together.
Ideally, right? Yes. Sounds great. I really like it. Then thanks much for the idea and also for joining.
Thank you, Santiago. Kudos to you, my friend, for putting this all together.
Thank you. I expected 4 people to join when I tweeted that. I said, okay, if I get 4 people, it would be great. And actually, when I saw like 800, 700, I was like, oh, this is gonna get out of my hands. So it's very nice to have people like you here trying to help us make it better. So I really appreciate it. That was also one of my goals for this call, to know all of you and start like knowing like if someone will take the lead on certain stuff, like you just did. So I know that next week I can run like the moderator hat during the call, answer questions in the chat. If someone paste the link on Zoom, I just move the link to Discord and stuff like that, and ask questions and become a student, that kind of stuff.
Let's go up there. I don't have anything to be here for. Come on, let's go. Up.
Perfect.
Let's go. Up.
And hopefully everyone can also stay silent, muted, and you're not speaking. That was a distraction for Santiago and for the rest of us as well.
Yeah. So yeah, this week was me doing all of that, but next week I will have more help. Thanks. So yeah, very excited for next week's. Anybody else more thoughts about it? If not, I think we can.
I have a quick question. So I was trying to copy the links from the chat to put them into Discord, but every time there's a new message, it would send me back to the top. Usually when I moderate a Zoom, it allows me to like export everything that was in chat. Do you have that capability, or should we just continue to try to copy it? It just keeps restarting every time.
Yeah, I think. Let me just save chat. I think after the call, I can access it.
Okay, amazing.
Yeah.
Thank you guys. Thank you for organizing. This is very helpful. Appreciate all of you guys participating.
Thank you for joining. Yeah, I have here the chat.
And everybody can do the same. I just saved the chat just as Santiago did on screen.
Great.
Anything else? Are we all good? Then no need to cover chapter 2 today, because we're going to cover deeply with Mash helps next week.
Right. Thank you so much, guys.
Thank you, everybody.
Thanks, everybody.
Thank you.
Thanks, Santiago. Thanks, everyone.
Have a fantastic day.
Thank you.
See you.
Thank you. Bye.
Apa-apa.